Good morning, one and all. Now, I am going to discuss a problem on diagonalize the matrix A equal to 1, 0, minus 1, 1, 2, 1, 2, 2, 3. Okay. Here, diagonalize the matrix means we can find out the, first of all, characteristic values and later the corresponding characteristic vectors, then find out the model matrix. That model matrix inverse, again we can find out. Then diagonal matrix is having the relation of P inverse AP. Okay, it is 2019 recent December question giving to you. Okay, first of all, what are the steps in the diagonalization means? First, we can find out the lambda values. Then we can find out the x1, x2, x3 corresponding the Eigen Vectors. Next, we can take the model matrix P is equal to x1, x2, x3 column matrices as a column in the model matrix. Then, if P is a model matrix, then we can find out the P inverse is equal to adjoint of P by determinant of P. Okay. Next, in the diagonal matrix, the relation with the model matrix is P inverse AP. We can find out the P inverse, then we can find out the relation of the or the product of P inverse AP. We are getting the diagonal matrix. In that, the diagonal elements are, what are the diagonal elements? What are the eigenvalues are there? Those elements are the diagonal elements in the diagonal matrix. Okay, this is a procedure of how we can find out the diagonal matrix. Okay, first I am taking the given matrix A. Let A is equal to 1, 0, minus 1, 1, 2, 1, 2, 2, 3. Okay, next we can take the characteristic equation. The characteristic equation is determinant of A minus lambda I is equal to 0. That is nothing but the diagonal elements. In that we are eliminating the or subtracting the lambda. That is modulus of 1 minus lambda, 0, minus 1, 1, 2 minus lambda, 1, 2, 2, 3 minus lambda is equal to 0. Okay. Now we can find out the determinant. The determinant is 1 minus lambda into elimination of row and column, then AD minus BC. That is 2 minus lambda into 3 minus lambda minus 2 ones are 2. Minus 0 into something is 0. That is 0 into 3 minus lambda into 1 minus 2 minus 1 into 1 2s are 2 minus 2 into 2 minus lambda is equal to 0. Okay. Now we can simplify. Here 1 minus lambda multiply of these two. 2 3s are 6 minus 2 lambda minus 3 lambda minus lambda into minus lambda plus lambda square minus 2 plus 0 in minus 0 into something is 0 minus 1 into 2 minus 2 into 2 minus 4 minus 2 into minus lambda plus 2 lambda is equal to 0. Okay. Now again we can simplify. 1 minus lambda into here lambda square minus 3 lambda minus 2 lambda, it is minus 5 lambda, 6 minus 2, it is plus 4 minus 1. Here 2 minus 4 is minus 2 plus 2 lambda is equal to 0. implies 1 minus lambda into lambda square minus 5 lambda plus 4. In the second term, we can take minus 2 common. Then minus into minus plus 2. Minus 2 common means it is 1. Here plus is there, minus lambda is equal to 0. In these two terms, taking common 1 minus lambda, the remaining terms are lambda square minus 5 lambda plus 4 plus 2 is equal to 0. Then here it is 1 minus lambda equal to 0 and lambda square minus 5 lambda 4 plus 2 is 6 equal to 0. Here lambda equal to 1. It can be split into factors. 6 factors are 3 2s are 6, then 3 plus 2 is 5. Minus 3 lambda minus 2 lambda plus 6 equal to 0. Lambda is taking common. Lambda minus 3. Minus 2 is taking common. Lambda minus 3 equal to 0. Factors are lambda minus 2 into lambda minus 3 equal to 0. Therefore, lambda values are 1, 2, 3. Okay. These are the lambda values. Now, we can find out the eigen vectors. The case 1. Take lambda equal to minus 1. Okay. Let x equal to x1, x2, x3 is a characteristic vector. Corresponding to the characteristic root. Lambda equal to 1. Okay. Here the characteristic vector equation is A minus lambda I into capital X equal to 0. Here lambda equal to 1. Therefore, A minus I into X equal to 0. This lambda equal to 1 value substitute in A minus lambda I, then we are getting the matrix into multiplication. Okay. Here lambda equal to 1 means then 1 minus 1 is 0, 0, minus 1, 1, 2 minus 1, 1, 1, 2, 2, 3 minus 1 is 2 into x1, x2, x3 equal to 0, 0, 0. Okay, that is the A minus lambda I means A minus I into X equal to 0. Here this is eliminating to 0, then R3 into R3 minus R2 and R1 and R2 rows are interchanged. Okay, then we can write 1, 1, 1, 0, 0, minus 1. Here 2 minus 2 is 0, 2 minus 2 is 0, 2 minus 2 is 0. x1, x2, x3 is equal to 0, 0, 0. Okay, now we can write in the equation form, that is x1 plus x2 plus x3 equal to 0 minus x3 equal to 0. Okay, here x3 is 0 means it is substitute in the above equation, it becomes x1 plus x2 equal to 0. Okay, we can take any one of the variable is a arbitrary constant. That is, take x2 equal to k, then x1 is equal to minus x2, that is minus k. Okay, therefore the characteristic vector is x is equal to x1, x2, x3 is equal to x1 is minus k, x2 is k, x3 equal to 0, minus k right outside, sorry, k out outside, minus 1, 1, 0. Okay, this is the x1 vector. Let it be x1 for lambda equal to 1. Okay, next we can find out the lambda equal to 2. Case 2, lambda equal to 2, take capital X2 equal to x1, x2, x3 be a characteristic vector corresponding to the lambda equal to 2. Okay, now we can write lambda equal to 2, then a minus 2I into x is equal to 0 is a characteristic vector equation. It is a characteristic vector equation. Here a minus 2I means 1 minus 2 minus 1, 0 minus 1, 1, 2 minus 2 is 0, 1, 2, 2, 3 minus 2 is 1 into x is x1, x2, x3 is equal to 0, 0, 0. Next, reduce these two elements are 0 by the row operation. R2 into R2 plus R1, R3 into R3 plus 2R1. Then A matrix becomes is minus 1, 0, minus 1. 1 plus 1 minus 1 is 0, 0, minus 1 plus 0 is 0, 1 minus 1 is 0. 2 plus 2 minus 2 is 0, 2 minus 0 is 2, 2 minus 2 is 0. It is x1, x2, x3 equal to 0, 0, 0. Then we can write in y, because it is shifted to R2 and R3, then it is in the echelon form. Then we can write in the linear equation form minus x1 plus 0 minus x3 equal to 0 and x2 equal to 0. Okay. Then here x2 0 means x1 is equal to minus x3. Take x3 equal to k, then x1 equal to minus k. Therefore, capital X2 equal to x1, x2, x3, that is equal to x1 is minus k, x2 is 0, x3 is k. K is taking outside minus 1, 0, 1. That is the x2 matrix. Okay. Next, case 3. Lambda equal to 3. Okay. Here let capital X3 equal to x1, x2, x3 be a characteristic vector corresponding to the characteristic root lambda equal to 3. Therefore, a minus 3I into capital X equal to 0 is a characteristic vector equation. Here, a minus 3I means 1 minus 3 is minus 2, 0, minus 1, 1. 2 minus 3 is minus 1, 1. 2, 2, 3 minus 3 is 0. To x1, x2, x3 is equal to 0, 0, 0. Here, these two elements are reduced to 0 by using of the row operation. R2 into 2R2 plus R1, R3 into R3 plus R1. Then A matrix is minus 2, 0, minus 1. It is multiplying with 2. 2 minus 2 is 0, minus 2. 2 minus 1, it is 1. And R3, these two, it is 0, it is 2. 0 minus 1, minus 1. Okay? Into x1, x2, x3 is equal to 0, 0, 0. Next, we can do this element is reduced to 0, R3 plus R2. Then the matrix becomes minus 2, 0, minus 1, 0, minus 2, 1, 0, 0, 0 into x1, x2, x3 is equal to 0, 0, 0. Okay? Next, we can write into linear equations. Once again, here we can check. Here, R2 into R2 plus R1, R3 into R3 plus 2R1. Here, R2 plus R1 is these two 0, these two 0, it is okay 0. R3 plus 2R1 means it is multiplied with 2. 2 minus 2 is 0, 2 minus 0 is 2, 1 minus 2 is here minus 1. So, here we are getting the little bit confusion. Okay, here we can write minus x1 minus x3 equal to 0, 2x2 minus x3 equal to 0. Here from this x3 equal to 2x2, take x2 equal to k, then x2 equal to k, from this x3 equal to 2k. x2, x3, then x3 is substitute here, x1 equal to minus x3, that is minus 2k. Therefore, capital X equal to x1, x2, x3 is equal to x1 is minus 2k, x2 is 2k, x3 is x2 is k, x3 is 2k. Then k is right outside, minus 2, 1, 2. Okay. This is the here k into minus 2, 1, 2. This is x2 matrix. Okay. Here, this matrix for case 3, that matrix can be written in the linear equation 2x1 minus 2x1 minus x3 is equal to 0, minus 2x2 plus x3 equal to 0. Here take x2 equal to k, then x3 equal to 2x2 equal to 2k. x3 equal to 2k minus 2x1 equal to x3. Okay, it is equal to x3 is 2k, x1 is equal to 2k by minus 2 is equal to minus k. Therefore, capital X equal to, that is x3, x1, x2, x3, that is equal to minus k, x2 is k, x3 is 2k. Then k is taking common, minus 1, 1, 2. Okay, minus 1, 1, 2. Here we are getting x3, x1, here x2. Now we can write the model matrix. The model matrix is therefore the model matrix P equal to x1, x2, x3, that is equal to, okay, x1 is minus 1, 1, 0, x2 is minus 2, 1, 2, x3 equal to minus 1, 1, 2. That is the model matrix. Now we can write all these. From the model matrix, we can find out the inverse. P inverse is equal to adjoint of P by determinant of P. Now we can find out the determinant of P. Determinant of P equal to minus 1 into 1 2 is 2 minus 2 plus 2 into 1 2 is 2 minus 0 minus 1 into 2 minus 0 minus 0 is 0. It is equal to 0 plus 2 2 is 4 minus 2 is equal to 2. Determinant of P is equal to 2. Here determinant of P equal to 2. Next, find the cofactor matrix. Cofactor of P, that is equal to matrix. Determinants of the minor matrices. Plus, minus, plus, minus, plus, minus, plus, minus, plus. Write the minor matrices. 1, 1, 2, 2, 1, 1, 0, 2, 1, 1, 0, 2. Elimination of middle row and first column. Minus 2, minus 1, 2, 2. Minus 1, minus 1, 0, 2. Minus 1, minus 2, 0, 2. Minus 2, minus 1, 1, 1. Minus 1, minus 1, 1, 1. Minus 1, minus 2, 1, 1. Okay, again we can check. 1, 1, 2, 2, 1, 1, 0, 2, 1, 1, 0, 2. Minus 2, minus 1, 2, 2. Minus 1, minus 1, 0, 2. Minus 1, minus 2, 0, 2. Minus 1, minus 1, 1, 1. Minus 1, minus 1, 0. Minus 1, minus 1, 1, 1. Last minus 1, minus 2, 1, 1. Okay. Now it is the cofactor matrix. The cofactor matrix 2 minus 2, it is 0. Here 2 minus 0 minus 2, 2 minus 0, 2, minus 4 plus 2, minus 2 minus outside, it is plus 2, minus 2 0, minus 2, minus 2 outside minus, plus 2, it is minus 2 plus 1, minus 1 outside minus, plus, sorry, minus 1, minus 2 plus 1, minus 1, minus 1 plus 1, it is 0, minus 1 plus 2, minus 1 plus 2, 1. It is a cofactor matrix. Next we can find out the adjoint of P. Adjoint of P is equal to transpose of the cofactor matrix 0, 2, minus 1, minus 2, minus 2, 0, 2, 2, 1. That is the adjoint of P. Okay. Next, P inverse equal to adjoint of P by determinant of P, that is equal to 1 by 2 into P matrix 0, minus 2, 2, 2, minus 2, 2, minus 1, 0, 1. It is equal to P inverse matrix. Okay. Now we can find out the P inverse AP is equal to P inverse matrix is 1 by 2 into matrix 0, 2, minus 1, minus 2, minus 2, 0, 2, 2, 1. A matrix 1, 0, minus 1. 1, 2, 1, 2, 2, 3. P matrix is minus 1, minus 2, minus 1, 1, 1, 1, 0, 2, 2. Okay. Now we can multiply the first or last, any you can choose. Product of these two matrices 0, minus 2 plus 2, it is 0, 0, 4 minus 2, 2, 0, 2 minus 3 minus 1. Product minus 2 minus 2 minus 4, 0, minus 4, 0, minus 4, plus 2, minus 2 get cancelled, and 0, 0, 2 plus 2 plus 2, it is 6, 0, 4 plus 2, 6, minus 2 plus 2, 0, it is 3, into minus 1, minus 2, minus 1, 1, 1, 1, 0, 2, 2 is equal to 1 by 2, and product 0, it is minus 2, it's 0, 0 plus 2, 0 into minus 1, 0, 2 ones are 2, 0. Next 0, 2 minus 2, it is 0, 0, 2 minus 2, it is 0. Next minus into minus, plus 4, plus minus 4, 0, minus into minus, plus 8, 8 minus 4, it is 4, it's 0, plus 4, minus 4, 0, 0, minus 6 plus 6, 0, minus 12 plus 6 plus 6, it's 0, minus 6 plus 6 0, 3 2s are 6, and write 2 by 2 is 1, 1 0 0, 0 4 by 2 is 2, 0 2 0, 0 0 6 by 2, 0 0 3. This is the diagonal elements. Okay, here after the product of P inverse AP, then we are getting the diagonal matrix, and it has lambda 1 0 0, 0 lambda 2 0, 0 0 lambda 3 value. This is equal to diagonal matrix when P inverse AP. This is the solution of the given matrix to find the diagonalization or diagonal matrix. Okay, this is a way. First we can find out the eigenvalues, next corresponding eigenvectors. Those eigenvectors write as a column matrices, that the combination of the column matrices is a model matrix. Next to find out the inverse. For the inverse, cofactor matrix, and transpose of the cofactor is the adjoint of model matrix. And to take the relation P inverse AP, we are getting the diagonal matrix. In the diagonal matrix, the elements are the eigenvalues. Okay, this is the procedure of the diagonalization. It carries the 10 marks question. If you like this video, please subscribe my channel and share to your friends. If you need any doubts, you ask me.